Very grateful to have Mike Starr here from Facebook. He's going to be talking about Dataswarm. So he uses all kinds of different data analytics to get insights into existing products and drive development of new products. So let's just have him talk about Dataswarm and how he leverages this big data. Thank you.
Thank you. Cool. Can everyone hear me? Everyone in the back? OK. My name is Mike Starr. I work here at Facebook, so I hope you guys have enjoyed our campus so far. And I work inside of an organization at Facebook we call data infrastructure. So I am not a data scientist, but I build tools which enable data scientists to do cool things. Today I'm going to talk to you about a system that we have internally here at Facebook. It's a system we call Dataswarm. If you saw the previous talks by the Parsley guys, this is the batch processing equivalent of their streaming pipeline. Or maybe you saw the previous talk by Stripe. They use a system from Spotify called Luigi. This is our equivalent to Luigi. But yeah, if you saw Burke's keynote yesterday, this talk may be more aptly named How to Move 300 Petabytes of Data. So let's get started. I'm going to start by telling you about one of my friends who works here at Facebook. His name is Neil. So Neil is a data engineer, which means that Neil looks at Facebook's data and tries to find useful, interesting stuff, right? So a couple months ago, Neil and his team started working on this new machine learning project that they wanted to do. And it had a structure that kind of follows this DAG-like thing. And for the rest of the talk, I'm going to refer to any DAG where you have tasks doing stuff and dependencies between those tasks as a data pipeline. So Neil needed to build a data pipeline to do something, right? And at first, Neil and his team thought about building a custom solution built off 0MQ. So here's what happened. Neil is a data engineer who found himself facing a lot of non-data engineering things. So Neil had to think about scheduling. How do I make sure that my machine learning pipeline is going to run every single day? He had to think about things like dependencies. So how do I coordinate tasks so that one task will only start after another one is complete? And then finally, Neil had to deal with things like fault tolerance for when stages of your pipeline eventually do fail. Do you know what Neil wasn't thinking about at this point? He wasn't thinking about number one, which is machine learning. So why is it that Neil, who's a data engineer, is thinking about so many non-data engineering things? So I argue that it doesn't have to be this way. I think that Neil should do machine learning. And I also argue that data scientists should focus on data science. It seems really straightforward, but this is actually like, it seems crazy, right? That should be the way people work, but it's not in reality. In reality, data scientists do a lot more than just data scientists. They write a lot of software. They write a lot of software that isn't about data science, but it's about launching their data science and doing, it's harnessing those applications. They also have to deal with things like deployment, right? So you wrote this awesome, great software suite, which is going to run some pandas thing or some NumPy or scikit. And you got to get it out into production and running on a bunch of machines. And then finally, once you do have it deployed, you've got to make sure that it keeps running every single day, right? And that sucks. It sucks that our data scientists have to think about this. But I argue that it doesn't have to be that way. I argue that data scientists can spend their days working on data science. They just need a little bit of help. And here at Facebook, that help comes from a tool we call Dataswarm. So what is Dataswarm? Dataswarm, at a high level, is the tool which enables data scientists to convert raw log data into useful information. It's the glue which ties together a bunch of different data processing systems, the main one here at Facebook being Hive, and coordinates those systems in such a way that useful stuff pops out the other end. Dataswarm is not a data engine, or it's not a database. It doesn't do any of the heavy lifting itself. Rather, it directs other systems and tells them what to do instead. This is just like a high level at Facebook, how data enters the system and flows through for batch processing. So it all begins with a person, like you guys, doing something on Facebook, right? You like the PyData conference page or something like that. That action leads to a web request on our backend servers. And those web requests then might generate a bunch of log events These are not just printfs to the console. They're structured log events which have certain meaning. And those log events are sent out through a system called scribe and then eventually loaded into our data warehouse. And that's where Neil comes in. Neil, yeah, thank you, Neil, for letting me use your picture. You're a good sport. So Neil comes in, and then this is where he decides he's going to do some crazy shit with 0MQ. But maybe he shouldn't, right? He's got to do something else. And that's where Dataswarm fits into the picture. So to motivate this example, we're going to do one of my favorite things to do at Facebook, and that's find cat GIFs. So we're going to write a dummy pipeline, both with and without Dataswarm. And the pipeline is going to find the top 10 cat GIFs shared on Facebook yesterday. And then we're going to try and post them to a group so that we can collect a bunch of likes from our peers and be awesome like that. So how do we find cat GIFs? We're going to break it down into a 3-stage pipeline. The first stage is finding cat GIFs. I'll leave that to the data scientists in the room who are way smarter than me to actually figure out how to find cat GIFs. We'll just pretend that we're going to look at the URL for GIF and then look at the title for cat, something like that. The next step is to dump those cat GIFs to a file, because files are great because you can run scripts on them. And then here at Facebook, we don't use Python for our web stack. We use PHP. So we're going to use some PHP code to actually post those URLs directly to a group. Sound good? So here we go. Here's the cat GIF finder post to a group pipeline in regular Python, no Dataswarm. It's not too complicated, right? We have this function called find cat GIFs. Maybe under the covers, that's doing a sub-process, which will run a Hive query or maybe using some connector. We have dump cat GIFs again. It takes as the input the output of the previous step, and will dump to a text file. And then finally, we've got the post cat GIF step, which again maybe would spawn PHP interpreter in a sub-process, and then post the cat GIFs to a group. Scheduling our pipeline is also pretty straightforward. Once we've tested and make sure it does the thing that we want to do it, we schedule it with cron, right? Cron's pretty straightforward. This is just, if you've never seen a cron string, this runs something every day at midnight. So life without Dataswarm is pretty straightforward. In a few simple lines of code, we're able to find and post cat GIFs to a group. And we're going to get likes in no time, that's for sure. But this pipeline maybe has some problems. Maybe think about it. Why would you not want to write pipelines like this every single day? I'll go over a couple of those reasons why writing pipelines like this might have issues. So the first thing you want to add to this pipeline is fault tolerance. That's easy in a non-Dataswarm world. We're going to create some decorator called call with retries. And what does it do? It calls something with retries when it fails. That's easy. It's just a couple, one extra little decorator. But what happens in reality, calling with retries doesn't always work, right? So let's say we're retrying on a machine, but it hasn't had its Hive CLI updated in 3 months. And now it's stopped working. I don't care how many times you try call with retries infinity, it's not going to run on that machine. Similarly, maybe the machine runs out of disk, or maybe the machine just dies itself, right? Retrying on the same machine means you're not ready for all realistic retry scenarios or failures. Because the reality of things are that is the machines die, right? So unless you're really and ready to retry things on multiple machines, you're not really ready to handle realistic failures. OK, let's talk about another thing that you might want to do with this pipeline, right? So you've already run the really expensive find cat GIFs query. So we don't want to run that step again. We comment it out. And we're going to do some work on the dump cat GIF step. But we don't want the post cat GIF step to run also, because then we're going to annoy all of the people who are part of our group every time we run our pipeline. We're going to repost the same cat GIFs. And they're going to be like, why am I seeing these 10 times a day, right? So commenting out, that works, right? Everybody's done this. Everybody has done this. You've commented out code, and you just run parts of the application that you find interesting. What is wrong with this approach is if you comment the code out, you inevitably will forget to uncomment it, and then you have to revert. It goes into production. And now you're feeling pretty dumb because you've broken your cat GIF pipeline. And then the third thing I'm going to talk about is remote execution. Remote execution, again, to get it right in its most basic form is pretty simple. We're going to define a remote command function, It accepts a command line to run, and then it will SSH to a free machine, run that command. And then you can start to build remote versions of all the things that you wanted to do. So for instance, we could do remote version of Hive, and it will find a free machine and then run a Hive query. Okay? So SSH, pretty straightforward. What goes wrong here? So this is actually code from Dataswarm when I joined Facebook. If you can't read it, it says, do not change these. Setting this inappropriately may bring down Dataswarm. Has anyone seen code like that? Yeah, that kind of code is scary. So, and what is it doing? It's got tasks per worker, so that's probably how many commands we want to run on any given host. We've got load threshold, so maybe we don't want to kill the host by working them too hard. And then we've got buffs threshold, so maybe something with memory, right? So here's the funny thing. This code was dead code when I joined Facebook. It didn't do anything. But everyone was so afraid by the comment that nobody wanted to remove it. So the moral of the story here is that, yes, running SSH is super simple. But running SSH in a reliable way when you've got hundreds of people doing it and machines dying all the time, it gets a lot trickier. So you don't want to build your own system to handle things like remoting just SSH. Use something that exists. So we've talked about 3 things that we want to do. We want to be able to handle retries gracefully. We want to be able to selectively run parts of our pipeline. And then finally, we want to be able to run our pipeline over a bunch of machines. Well, and hopefully somewhere along the lines, we come up with something more reliable than cron because, again, that's not realistic for scheduling things in production. So life without Dataswarm is basically this eternal struggle. You're always going to be fighting against the way that you've written your pipeline in the first place. So the real problem is you've written in your pipeline in a way which makes it hard to tackle these 3 things. So don't do this, OK? It's simple. Don't write pipelines like this. Instead, what you want to do is come up with some abstraction, some framework, which can enable you to focus on machine learning and not focus on these stupid problems that you don't want to deal with. If you saw the previous talk by the Stripe guys, there's an open source tool called Luigi. Look into Luigi. But here, today, I'm going to talk about Facebook's solution to this problem. And hopefully, you can learn from our mistakes in our design. So there are 3 kind of problems that Dataswarm is meant to solve. And it solves them in this way. Dataswarm rethinks pipelines by introducing 3 new concepts. The first concept is the task. So that's something that has a .execute method. It just does something. I don't care what it is, but it can run itself. The second thing Dataswarm introduces is dependencies. So tasks can depend on each other. In this way, we're building a dependency graph. It's an acyclic graph. Otherwise, things will never start. And then the third thing that Dataswarm realizes is something that machine learning data scientists want is scheduling. So you want to be able to have a snapshot of your graph run every single day. And maybe there's some kind of implicit self-dependency when you have things being scheduled this way. So as you'll find out, though, that Dataswarm does not Dataswarm takes a declarative approach to defining this dependency graph. And I think Burke put it in a really good way. Dataswarm in its heart is a dependency graph description language. So the code that you'll see is not actually code that runs to completion and does anything. Rather, it just defines what you want to do. And it's up to Dataswarm and Dataswarm's infrastructure to actually figure out how to go about executing your pipeline and what it is that you want it to run. So let's revisit now the cat-gif pipeline written as a Dataswarm pipeline. OK, so this is all the code. We'll go through it line by line so that you can see all of the important parts. So the first thing I'm going to talk about is this global defaults construct. So what global defaults does is it sets default parameters for every task that we're going to instantiate inside of this pipeline. It does this under the covers with a simple magical decorator. So what I'm doing here is I'm saying that every task that I define in this pipeline hereafter should default to be owned by Starr, which is me. And it should default to have a schedule of @daily, which is just an alias for the cron string equivalent that we saw before. Everybody understands @daily. Not everyone understands 00 star star star, right? So global defaults sets default parameters for everything in this file. The second thing we're going to look at is how do we start telling the Dataswarm that we want to do some work. So the way you tell Dataswarm you want to do work is by creating instances of operators. An operator is something that has a .execute, and in this case, we're creating an instance of a class called HiveQL operator. What does HiveQL operator do? It runs a Hive query. And as such, it requires the Hive query parameter. And you'll note that we assign the HiveQL operator to a variable named findCatGIFs. Remember this. So then the third thing to note is how do we specify dependencies between tasks? You specify dependencies between tasks by passing in a list to this parameter called deplist. Deplist is short for dependency list. So what you do is you pass in a list of the other tasks which need to be completed before this task will begin running. You'll note that it's not a string identifier or anything like that. It's actually the object instance itself, which means you could depend on things that are outside of your module simply by importing them. Kind of handy. So you'll see in the second step, we have a new class called Hive2File operator. You can guess what that one does. It runs a Hive query and then dumps the results to a text file. So we have Hive query and then file path. Those are how you specify those two things. So you'll notice inside of our Hive query, the first thing is where ds equals date ID. So ds is like a convention used at Facebook for date stamp. And then this date ID, that is definitely not a date stamp. So what's going on here is that date ID is actually a macro. Its value will be expanded at runtime to take on the value for which this task was scheduled. This is a super powerful concept because what it means you can do is run your pipeline for arbitrary dates of time. Right? I can run the same pipeline against yesterday's data, a week ago's data, or a year ago's data. So if I found out there was crappy data in the system a month ago, I can rerun for all of those steps. The other macro that we see here, again, there's file path equals temp file. It acts just like the temp file module. It's going to create a temporary file which is accessible by all of your tasks under the same name. You don't need to know where that file ends up. You just know that it can be accessed by all of your tasks. And then finally, we have PHP operator. Runs a PHP script, or in this case, PHP statements. And again, we're saying via the dep list that it depends on the dump catgifs step. So if you've been following the dep lists along so far, you'll know that the pipeline is going to run the 3 steps serially so that nothing happens out of order. And again, we're assigning the PHP operator to a variable named postCatGIFs. Remember that one too. OK, so recap. We've got this global defaults construct, which is used to set default parameters for every operator we instantiate. So user is a required parameter, but we never had to explicitly set it for any of the operators in this file. We've created 3 instances of different operators that specifies how we want what the pipeline should actually do. And then we've specified the dependencies between operators so that we can say, first run find catgifs, then dump them, then run the PHP script. OK, so any questions so far? Yeah. Oh.
Yeah, I have sort of 2 questions. Number one is, you're giving us examples of Hive queries. Do you support arbitrary code modules? And second of all, if the dependency list is more than 1 item, do you have like a special class that defines an aggregator from the output of multiple items?
I'm not sure what you mean about the aggregator, but for the operators themselves, pretty much anything that has a .execute, you can do whatever you want there. Import any Python library, define whatever you want as your core step.
So if you have multiple dependencies, you might not, you want to specify basically how you join or otherwise aggregate the outputs of those dependencies. Like, how would you go about doing that? Do you have an example of that?
I think that's really up to how you define your pipeline. The dependency list is only for specifying which tasks actually need to run before. How you aggregate their results is really up to you. Actually, I'll just keep going and leave questions for the end. So the first thing to note is that this is Python code, but it kind of doesn't look a lot like Python code, which is great for non-engineers. If you have never written Python before, this is something you can pick up. and you could start writing pipelines. And that's good for Facebook because we have a lot of people who maybe aren't very familiar with Python, but they're HiveQL wizards. The second thing to note, but at the same time, because this is regular Python code, there was nothing stopping us from defining our operators inside of a function, or a class, or a for loop. And we'll get back to this fact in a more complex example later, but just keep that at the back of your mind that there's a lot more to this than meets the eye. And then the final thing to note is that there's no main, right? No underscore underscore main. There's no .execute, there's no .run. The pipeline just is. It exists, and that's it. So that begs the question, how do you actually run this darn thing? So running the pipeline is actually delegated to a different script. You test a pipeline with the tester script. So that's the one we're going to talk about today. So to run the pipeline, we pass in the path to the file that we want to run, and then we pass in the date. Again, this date is not the date at which the pipeline is running, but rather the date for which it's scheduled. And that gives us that ability to shift things throughout time. If you hit enter with that command line, what you're going to see is some log output like this. It'll tell you what it's executing in order. It'll start executing things one at a time. And then with the tester as is, it's just going to print the logs to your console. So there's a couple things to note here. The first is that all of the tasks, their prefixes, are actually just the module name from where we're imported, less the tasks prefix, right? So all of our tasks were defined in DI example, catgif example, and that's the module name, and that's also the prefix. This has the nice property that you're not going to have naming conflicts because unless you define the variable and then overwrite it inside of the same file, you're not going to have two separate pipelines stepping on each other's toes. The second thing to note is the task ID suffix. That's actually the variable name that we had assigned inside of the module, right? So we had 3 steps: find catgifs, dump catgifs, post catgifs. Those were the variable names, and now they're part of the task ID. So taking the module name combined with the task, the variable name, put those together, and you have the task ID itself, and it's a unique way of identifying any Dataswarm operator. And then the final thing to note again is we always pass in a date. So the date specifies for which context this pipeline should be run under, and then that will later be used by the pipelines when expanded as the date ID macro or through other mechanisms. So to recap, Dataswarm's primary abstraction is the operator scheduled at a specific date. Our users write Python code which defines the pipeline, and it's actually delegated to these driver scripts to actually run this stuff. And by doing this, we can start to address all of those problems that we originally mentioned. So first, let's revisit fault tolerance. So fault tolerance inside of Dataswarm is really straightforward. You add num retries to global defaults, and everything is going to retry 3 times until it fails. Again, because this is just the default parameter, you can override stuff when you create an instance at instantiation time. If you had this and ran tester locally, you're going to see something like this. If the catgif step fails, we're going to sleep some defined amount you can provide, and then we're going to retry until we've exhausted all of our retries. Selectivity is also easy this way now that we've defined our pipeline rather than telling us how to run the pipeline. So we've already seen that one way to run a pipeline is just to pass in the Python file itself, and everything will be executed respecting dependencies. But we could have passed in a single task, right? Because it's up to the driver script, passing in this command line would only load the dump catgifs operator and only call .execute on that. So we can avoid the whole issue of commenting things out of our pipeline because, again, the pipeline definition is separate from the execution context itself. We can also do fancier stuff like regular expressions. So maybe we want to only run stuff that matches some common prefix or common directory. And we can get even more fancier and more fancy and do stuff like include dependencies of one single task. So this would specify a task and then run everything that is upstream of it. And then the other thing we mentioned was remoting. So with Dataswarm, we actually kind of cheat. We didn't write the system within Dataswarm, but rather we use another system inside of Facebook, which is called Kronos. Kronos is actually very similar to, I think it's Airbnb. They have their own tool, which is also called Kronos. And what Kronos does is it's a thrift service inside of Facebook, which lets us run arbitrary shell commands. And it lets us monitor their progress and then view the historical logs and things like that. So again, if you're working on a system like this for yourself, don't build it maybe necessarily into your own Dataswarm equivalent, but rather find some system which is good at handling remoting for you and cheap. So if you run Dataswarm tester with -- remote, what's going to happen is instead of printing the logs to the console, it's just going to print out a URL. And that URL will take you to a dashboard where you can actually track the progress of your pipeline rather than try to parse the logs all locally. In this case, you can see this is launching. It launches all 3 of our tasks at the same time. The dependencies were registered with Kronos now. And then Kronos will take care of running things in order because that's how Kronos can handle some dependencies. One added side effect to -- remote is because you've only specified how many retries you want to have, we can implement different retry policies using these driver scripts. So in this case, if we have -- remote and retries configured, what's going to happen is if a task fails, Kronos will retry that command on a different machine. So that means we can avoid an entire class of failures due to host failure, right? After you've tested your pipeline, you've run it with tester, you've run it on -- remote, and your peers think you're doing something that actually is useful, it comes time to schedule. And scheduling is actually as simple as checking your pipeline in for Dataswarm. Once you check your pipeline in, Dataswarm scheduler will pick up on the new or updated files and then begin scheduling. It's pretty much that simple. And then once the tasks are scheduled, we have a UI which you can use to maintain and disable pipelines without actually taking out their code. So once you've checked in the cat-gif pipeline, you'll see something like this. The first thing to note is the task IDs. Again, they show up here, and they're nested based on dependencies. So you can collapse and expand different sections of the dependency tree. We've tried a lot of graph-based viewers, GraphViz, D3, all of those things. So far, we haven't found anything that works better than nested tables. Everything else just looks crazy. And then the second thing to note is history. So for each task, in this case, my pipeline was running fine for the last couple days. And that makes it easy for me to tell that. We just look at the history for each task across time. But it also would make it easy for us to identify failures. If you do perhaps identify a failure, we have a bunch of maintenance tools that you can use from the UI. For instance, you can do things like clear and restart an instance. Or you could even backfill an entire task or selection of tasks across time. Because maybe you know that some upstream table which you depend on had wonky data for last week, and you want to rerun the entire pipeline for a week. You would just go to the UI, select those tasks, and then kick off a backfill, which would run in parallel on the Kronos hosts. We also have a couple of other bells and whistles, too. We have a Gantt chart view, so you can see where your pipeline is wasting time. This one's not super interesting because it's generally a serial pipeline. We also have a historical landing time view. This was actually recently added by one of our customers, not a Dataswarm dev itself. And what this will do is show the tasks' arrival times for each step in your pipeline across time. And what that can let you do is it can let you identify places which need improvement, and then also see, did your perf change actually lead to an improvement or maybe a regression? OK, so earlier on, I mentioned Dataswarm. The pipeline in the cat-gif pipeline is pretty simple, right? So now let's talk about start to hint at the full power of Dataswarm. And so to do that, we're going to do another example. In this case, we're going to build a service to replicate Hive tables into MySQL. But here's the gotcha. The Hive tables need to be specified not from Dataswarm Python code. We want them to be specified by people who have never touched Python in their life. And we want them to be able to provide the query from a UI. Right? So they're not going to type any code, and they need to specify the Hive query, which is going to be run and then loaded into MySQL. So how would we do that in Dataswarm? So again, the big advantage is Dataswarm is regular Python code. So you can start to write functions which generate pipelines rather than write them manually. So here I've defined a two-step pipeline which is going to be returned from a function called getReplicationPipeline. So getReplicationPipeline accepts a table name. It will create, and then it will create a two-stage pipeline where the stages are serial. The first one is create. So we're going to run some MySQL query, which will create a table, and then replicate, which would actually run some Hive to MySQL stage. But we said the whole thing needs to be specified from the UI, right? And here I've hard-coded MySQL query and Hive query. And this would totally not work in a general sense. But that's no problem. Because the Hive query and MySQL query themselves could have been returned from another function. And maybe that function imported the Hive Metastore API, looked at the schema of the table or parsed the query that was about to be run, and then generated dynamically the query that's actually meant to load this table from Hive into MySQL. Putting it all together, again, we're going to read the list of tables to be replicated. And we can do that again from a function, which is maybe actually talking to a backend DB, which was populated by the UI. And then we're going to generate the pipeline for each table that we want to replicate. So these are some toy examples. In the real world at Dataswarm, at Facebook, Dataswarm runs virtually every batch processing pipeline that we have. And that does accumulate to processing nearly 300 petabytes of data. For a few examples, we have a bunch of these replication services. They're obviously more complex than a two-stage pipeline, but you get the gist. We have tons of people using them for machine learning. We have an A/B testing framework called Deltoid, which was built entirely inside of Dataswarm, where the experiments themselves are defined in a UI, and Dataswarm constructs an A/B test from the UI rather than having people write code. And then finally, it's used by a bunch of different organizations, pretty much all of them, BI, ads, search, security, you name it. So the key takeaways I hope you get from this talk, since Dataswarm is not open source, is don't try. Maybe you need to build a tool like Dataswarm yourself. But at the same time, just realize that you don't have to put up with the pains of managing a pipeline execution service. There are tools like Luigi that exist, which you should consider. But don't put up with the pain. Find something that works for your team and use it. It's really that simple. The way we do that at Facebook is by taking the whole pipeline problem and abstracting it into 3 separate concepts: the tasks, the dependencies, and then schedules. And rather than using Python as an execution context, we just use it as our definition language. Yeah, so with Dataswarm, we found that our data scientists really can spend all of their days working on data science. It's crazy. Thank you. Any questions? 7 minutes. Yeah.
So if I understood correctly, you have basically a cluster operating system, something similar to maybe Slurm or SunGrid Engine or PBS, but you have a Python interface and you have a web UI that you can use, and it allows you to send many of those and handle dependencies.
Yes.
Which a lot of those systems do. But one thing that I haven't seen in those is your ability to retry some of those tasks in case they fail.
Sure.
So did I catch this correctly? Is there something else that those systems do not have that you do have?
I'm not entirely familiar with those systems, but I can tell you what Kronos does. So Kronos is a system. It's a pool of machines which are managed by a scheduler. And what you can submit to Kronos, you submit to Kronos via a thrift interface, a job definition, which is really just a command line. That command line accepts parameters, so you can use the same job, but maybe tweak it just a little bit. And then Kronos also does support the notion of dependencies between jobs. So the way Dataswarm would work in that previous example, when you run tester, it's going to submit 3 separate jobs and register within Kronos the dependencies between them. And then Kronos, by default, out of the box and always, will do retries across different machines. Yeah.
So I was curious for the sort of the dependencies, they have these working sets that they output. Let's say that they output a working set to 2 or 3 machines, and then all of those machines fail. So you want to retry the task on a separate machine. How do you handle the problem of data locality?
So we don't make any data local ever. That's what we do. The Kronos machines, I think their like local disk is like 1 terabyte, which for some people, like if just 2 of their pipelines ran on the same machine, it would be totally hosed. So we use networked storage mounted via NFS. So like things like NetApp or Gluster, never local. With the caveat, you could do local if it was all within the same task. But across tasks, we require you to use something that's networked. Yeah. I'll just repeat it.
So somewhere in the GUI, there was a depends on history, and there was a tick button.
Yeah.
Can you elaborate on what's possible? And
Sure. So the question was on the GUI, there's this depends on past column. So depends on past is just like an extra parameter. I didn't go over all of them, which says whether a task has that self-dependency. So in some pipelines, like if you depend on yesterday's data, you obviously can't run today's version of that pipeline until yesterday's is completed. So that basically means you want to halt all execution until all previous runs have succeeded. But for other pipelines, maybe it doesn't matter, in which case you just want to drive through failures, and you would set depends on past equals false. I don't depend on past versions of myself. Yeah.
So by default, for each, do you store data separately for each day, or does it overwrite the previous data?
Yeah. So the other question was, by default, do we save data or overwrite? We highly, highly, highly recommend everybody always do overwrite because it's idempotent. If you do insert into, you're going to have a bad time. It's as simple as that. Yeah.
So just to make sure that I understood correctly, you let your users define their own operators besides the built-in operators?
Correct. So we have a core set of operators that just makes sense, right? HiveQL, MySQL, Oracle, like every data source under the sun at Facebook anyway. We have an operator for that. We have one to like load data between each other. And then we have stuff for running scripts. Yeah. And those, the core Dataswarm team, we manage and make sure that people don't do stupid things or like unexpected things. But yeah, all you really need to do is subclass base operator and then implement your own execute method.
So, I mean, given that your users may create their own operator, can they install external packages within those operators? And how do you manage that?
Yeah.
Especially if machines fail, you need to install blah, blah, blah.
That's a good question. So Burke mentioned at Facebook, we have this build system for Python. And basically what it boils down to is you have a list of things, other modules which should be installed. And then what we deploy to all of our hosts is like a self-extracting shell script, basically, which has all of your dependencies. That being said, it's still somewhat of an open problem. We're looking to make it easier for people to like hook in dependencies that they want to use without them being distributed by default, because maybe their dependencies don't make sense for everybody. And for that, we're still exploring some options that are basically going to do something along the lines of like downloading a package, adding it to syspath and LD library path, and then like try to remove them secretly between pipelines. But yeah.
How many of those jobs can you handle? Like, is it actually like, can you handle hundreds, thousands of jobs? Even small ones that are scraping something or doing something, and if you do, what happens in case of a mistake? Someone presses the button and says, "Oh no, I need to delete all of those because I had to add this line." Like, do you have any scripts that can delete them and start again? And
Sure. So how many can we handle? Dataswarm, the scheduler itself, is actually a dispatcher. It just needs to figure out what's eligible to run. And then Kronos itself is written in Java, and it can handle, I think it runs like on the order of like millions of jobs per day. I don't know. It's a lot. As your question on like, what if I accidentally launch off a bunch of jobs? Funny story. I once was on call for our team, and this one guy who's like a really big customer of ours, kicked off a backfill starting in not 2013, but 2012. And Kronos happily accepted his twice as much as he had expected. So we have a whole bunch of tools for like killing off stuff in parallel. We have a bunch of other like extra tools which can do things like restart all Kronos jobs which failed with this in their log message for like more bizarre failure scenarios. But yeah, we basically have separated Dataswarm. The scheduler is really just a dispatcher. And then all of the work of finding a free host, we've delegated to Kronos. And Kronos does that with timers and things in Java.
All right, let's thank our speaker and get ready for the keynote. Thank you.